Okay, so this time let's identify the elements of matrix. Let's talk about elements of matrix. So normally elements of matrix is defined as, so we have a big letter A followed by I and J. Big letter A, I and J. Okay. Now to identify the elements of matrix, given this sample matrix, let's get the element of this first matrix. What is the element of this first matrix? So basically, it is located at row 1 and column 1. So therefore, A, row 1, column 1 has a value of 1. Okay? And then, let's try to identify the elements of this. So when we say elements, it is about the position of the number. Okay? Element 2 is, still we are on row 1, so that is why we have to write here 1. But we are already on row 2, so that's why we have to write 2. And this is 2. And then, for number 3, we are on row 1, but we are on row 3. So this is 3. And then, for our number 4, we are on row 1. We are on row 2, but column 1. Okay? So this is 4. And then, for 5, we are on row 2, column 2, that is 5. And then row 2, column 3, that is where our 6 is located. So let's keep doing this. For 7, this is on row 3, column 1. For 8, we are on row 3 and then column 2. And then for the last element we have, that is 9. So 9 is on row 3 and column 3. That is 9. Okay? So that's how you identify the elements of your matrix. Okay? So now let's talk about square matrices. Square matrix. Square matrix, a matrix with same number of rows and columns. Two matrices are equal if they have the same size. The same size and shape. Same size and shape. So this is what we call the order, and all elements are equal. Okay, so square matrix, so when we say square matrix, this is a matrix with same number of rows and columns. And another thing, two matrices are equal if they have the same order. When we say same order, the size and shape, and all elements are equal. So this is the definition of square matrix. Okay, so let's have an example of this. So for example, we have 1, 3, and 5, 2, 4, and 6, and then another matrix here. We have 1 and 4, 2 and 5, 3 and 6. So now the question is this matrix equal to this matrix? Okay, but before we answer that, let's go back to the definition of the square matrix. Square matrix should have the same rows and same number of rows and same number of columns, and at the same time the elements are equal. So how many rows do we have here? So this is 3 by 2. What is the order of this? This is 2 by 3. And then look at the elements. So they are not equal. Just looking at the orders, they are not already equal. The order of this is 3 by 2, and the order of this matrix is 2 by 3. So they are not equal in the order. So therefore, this is not equal. Okay. So let's have another example. So let's try this example. Are they equal? Do they have the same order? Okay, so what is the order of this matrix? So this is 2 by 2, and this is also 2 by 2. 2 rows, 1, 2, so that's why we have 2 here. 2 columns, 1, 2, that's why we have 2 here. 2 rows, 1, 2, 2 columns, 1, 2. Okay, so they have the same order, but do they have the same elements? Well, I guess not, because we have 31, okay, that's fine, they are equal. 79, they are equal. 31, they are equal. However, on this part, this is 0, and then the other side is 10. So this means that these are not equal. Okay, so let's have another example. Let's say our matrix is okay. So let's start with the order of this matrix. So what is the order of this matrix? So let's count. How many rows? We have 2. 1, 2. How many columns? 1, 2, 3. So we have 2 by 3. On this side, we also have 2 by 3. 1, 2, 2 rows. 1, 2, 3, 3 columns. So they are equal in terms of the order of the matrix. Now let's look for the elements of this matrix. Do they have the same elements? So let's examine. 7, 7, 3 and 3, 4 and 4, -1 and -1, 2 and 2, 3 and 3. So they have the same elements. So this means that this is equal. Okay, so that's all for square matrix. Okay, let's have a few more examples. Let's say we have 4, -6, 7 and 8, 5, -1. Okay, now the question is, or the questions are, we have to find the order, we have to find the element, and then we have to find also this another element. Okay, so let's start with the order. What is the order of this matrix? So let's count. 1, 2. So we have 2 rows. Let's write here 2. How many columns? 1, 2, 3. So the order of this is 2 by 3. Okay, what element is positioned or located on this position? A sub 32. So when we say A sub 32, the 3 here pertains to the column, pertains to the row. So how many rows do we have? 1, 2. We only have 2, but we have 3 here, so meaning this does not exist. A32 does not exist. So let's write here A32 does not exist. A sub 23. So let's look for matrix row 2 column 3. Row 2 column 3. So this is -1. Okay. Let's have another example. Let's try this one. -1, 0, -2, -5, 7, 1/2, pi, -6, 11, and then another pi here, and then 1/5. Okay, so let's identify the order. What is the order of this? Let's look for the value of this element. order of this, so let's start identifying the order of this matrix. So let's count the number of rows. 1, 1, 2, 3. So we have 3 here. We have 3 here by 1, 2, 3, 4. 3 by 4. And then let's identify what number can we get from this element, from this position. So row 3, so this is our row 3, column 2. Okay, so we have 1/2. And then row 2, this is our row 2, and then column 3, this is our column 3. So we have -6. So that's it. So that's how you identify the elements and the order of your matrix. Okay, see you in the next lectures.